In the last video, I did not finish simplifying radicals, so this is simplifying radicals part 2. Down here I'm on number 10, and we were looking at this cube root of 216 and looking at this list. Hopefully you notice, look, 216 is in the list. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. So the cube root of 216 is 6. That one was super easy. Isn't it nice when it comes out that easily? Okay, now look at number 11. Not quite as easy because 250 is not in my list. And quickly I want to talk about variables. X to the third is a perfect cube because x times x times x is x to the third. X to the sixth is a perfect cube. X squared times x squared times x squared is x to the sixth. X to the ninth is a perfect cube. X to the third times x to the third times x to the third. Y to the 12th is a perfect cube. Z to the 15th is a perfect cube. So can you generalize the rule here? The relationship is they are multiples of 3. I apologize for that. Multiples of 3 exponents of variables are perfect cubes. Okay, so is this a multiple of 3? Yes, so this one's good. Now, how about 250? Which of these perfect cubes will divide evenly into 250? Hopefully you automatically see 125. I'm going to keep that negative out there. It's a negative 1 out there. And I'm going to have the cube root of 125 times the cube root of 2. Is that right? 2 times 125 is 250 times the cube root of x to the 12th. So negative 1 times the cube root of 125 is 5. I cannot take the cube root of 2, so I have to keep that. Times 3 divides into 12 4 times. So multiply all the things that don't have a radical. Negative 1 times 5 times x to the 4th is negative 5 x to the 4th. Keep your cube root of 2. And be careful, make sure you have that little 3 there. If not, that answer would be incorrect. Okay, this one. Normally my advice would be to students before they separate this would be to reduce these two. However, this is a perfect cube, so I really don't want to reduce that. I want to keep that 14, and I want to take the cube root of a perfect cube. So be careful. My advice normally is reduce before you take separate radicals. But this time, that advice does not hold true. Now, I'm going to do this. I'm going to keep 14m here. Hopefully, you'll understand m squared. I'm going to keep 14m squared here, and then I'm going to take and have the cube root of m cubed up top. Why did I do that? Why did I separate that and turn the cube root of 14m to the 5th into these two separate radicals? Well, there's a multiple of 3 within 5, and that's 3. So m to the 3rd times m to the 2nd would be m to the 5th. So make sure you think about that as you're going along. And then I do have the cube root of 64 times the cube root of n to the 21st. Now let's find that answer. I cannot do anything with this. There's not a perfect cube within that, and so I've got to keep the cube root of 14m squared on top, m squared. And then the cube root of m cubed is m. I'll put that out front. And then the cube root of 64 is 4. And the cube root of n to the 21st is n to the 7th. So this is my answer to number 12. On to number 13. Now this is the reverse. I'm going to ask you to do this first. Rewrite that as one radical. I did that because I realized 5 goes into 20. I can reduce that into the square root of 1/4. Both of these are perfect squares. The way this was written, I couldn't do that. So now I'm going to have the square root of 1 over the square root of 4. The square root of 1 is 2. No, it's not. Ha ha. The square root of 1 is 1. The square root of 4 is 2. There's where that 2 comes from. So the answer to the square root of 5 divided by the square root of 20 is 1/2. The next one, I'm going to rewrite this. I can't reduce. As I look at that, I can't reduce. So I'm going to rewrite this as the square root of 12 over the square root of 121. I see automatically that the square root of 12 can be rewritten as the square root of 4, whoops, times the square root of 3 and then 100 square root of 121 is 11. I've got one more step to get that answer. The square root of 4 is 2. Can't do anything with the square root of 3. And bring 11 down, and that's my answer to number 14. One more to go, and then we're finished. Okay. As I look at this one, 2 is not a perfect square. I can't do anything to it. Both of these are perfect squares, so I can rewrite that so you can see. Square root of 2. And then on the bottom, the square root of 16 is 4. I can't do anything with that, so I'm going to keep the square root of 2. The square root of x squared is x. The square root of y to the 4th is y squared. And I have 4 on the bottom. And you cannot reduce something that's under a radical with something that's outside of a radical. So this is my answer to number 15.